Hi, my name is Denise Mitrano. I'm Assistant Professor of Environmental Chemistry of Anthropogenic Materials. I'm initially from the northeast of the US, New Hampshire. That's also where I did my undergraduate studies at Salve Regina University, where I studied both chemistry and biology. After moving from New England, I went out west to the Rocky Mountains, where I studied at Colorado School of Mines and got my PhD in geochemistry. After leaving Colorado, I came to Switzerland and have been here ever since. I did my postdoc at EMPA, the Swiss Federal Institute of Material Science and Technology in St. Gallen. And after finishing my postdoc there, I got an SNF Ambitione grant to start my own research group at EOVAG, the Swiss Federal Institute of Aquatic Science and Technology. Since July 2020, I've been here at ETH. So understanding the materials that we use in our modern society and how they impact the environment is important, because knowing what adverse effects might happen can help us redesign materials so that we're better able to make sustainable materials in the future. There's two types of materials which we're focusing on, which is engineered nanomaterials and plastic and microplastic pollution. For engineered nanomaterials, we're always wanting to use these products to be able to increase the functionality or utility of other materials, but we're interested in how they may be released from products during their life cycle and have negative environmental impacts. In the case of plastic, it's quite clear the negative impacts which are happening because of plastic pollution, but it's less clear about what specific fate and transport processes might be happening and which specific impacts the plastics may have. As an analytical chemist, my role is to be able to measure how much plastics or nanomaterials there are in the environment and understanding the mechanisms and processes which are making them move through the environment. With this information, we may be able to make better materials in the future which have less environmental impact. So there's three main research themes which underpin the research that we do in the group. The first is developing new methods for trace analytical chemistry, which is usually for different types of particles and metals in the environment. The second is looking for fate, transport, and transformations of particles as they move through different environmental systems. This can either be in freshwater systems, such as lakes or rivers, or it can be in terrestrial environments, such as agricultural fields or soil. Lastly, we're interested in a safer by design approach that once we know how particles move through the environment and the impacts that they might have, we may be able to better design materials for a more sustainable future.